Okay, so this video is going to be about fraction division again, except for tonight's focus is about taking a fraction and dividing it by a whole number, whereas last night's was a whole number divided by a whole number as well as a whole number divided by a fraction. In class, though, we talked about a pattern that we kept seeing happening over and over again, that, you know, the first term was always kept the same. We were always changing division to multiplication. That's what we would do in our mind to solve it. And it was always like we were flipping that other one or finding the reciprocal of that second term. So that we talked about something like maybe if we keep this and we change it to the inverse and we flip, that it might work. And they, through class, they kept proving this hypothesis that Katie Webb had come up with. And it kept proving true over and over again. So then we worked on creating then an equivalent multiplication sentence for division problems. And as again, right now the focus is a whole number divided by a unit fraction and a unit fraction divided by a whole number. Again, that unit fraction means that 1 is the numerator. So then they have their homework. It's page 515. And it looks like this. It says lesson 8.4. And they have to do the even numbers up top, but on the bottom they have to do all three of the bottoms, the 13, 14, and 15. And they need to use Kita. That's where they pretty much restate the question and the answer there. So, for instance, in class we worked on problems like this. We had something like 1/3 divided by 4. And so we said, okay, if we need to write a multiplication sentence, then if we keep 1/3, we change the division to multiplication, since that's what we were doing in our head, and we flip 4. And it was hard at first, but the kids got caught on that 4 is actually standing on top of 1, because all whole numbers do, because 4 divided by 1 is still 4. It doesn't change the value. So if you flip that, the reciprocal of 4 over 1 is 1 over 4. So we get 1/4. Okay, so then they know how to do a fraction times a fraction, so you get 1/12. So 1/3 divided by 4 is 1/12. We also talked about that dividing by anything is taking that of the other number. For instance, if I am dividing by 1/4, then I am taking 1/4 of what I started with, 1/3. So I am taking 1/4 of 1/3. I am writing it backwards only because of the keep, change, flip thing. I don't want them getting confused with what's the starting point, which was 1/3. So I am writing it backwards, 1/4 of 1/3, and of means to multiply. So you still end up with that first term staying the same, changing to multiplication, and then flipping, finding the reciprocal of the second one. So that is basically what their homework is doing, is replacing the division number model with the multiplication number model that goes with it to help us solve it, and solving it. So another example would be like when they do a whole number. So they did something like this in class. So keep this, we do nothing with this, keep it, change this to the inverse, flip 1/5. So if we flip 1/5, I told the kids, I imagine it's like I flick it and it's spinning around and then it lands upside down. So the 5 is on top, they switched around. And we also talked about that 5 divided by 1 is understood, but technically we don't need to write it as 5 over 1 unless you absolutely want to. They could just understand that 5 divided by 1 is 5. So that we got the answer of 30. And some classes got to a number line and some did not. So I quickly want to go through what that looks like. So back to the 1/3 divided by 4, I'll do that as a number line. So the problem is 1/3 divided by 4. On a number line, it is the 1/3 that we're actually starting with, right? That's what's being divided up. So 1/3 is actually what goes on the number line, not the whole number, whereas last night it was the whole number being broken into that many parts. So it is 1/3, and it is being broken into 4 parts. I do need 4. So I've got, here's one part right here, 2, 3, 4. So I took a third and I divided it into 4 equal, again we're pretending, sections. So that means that if I start counting, then I know this is 1 over something. I don't know yet. And this would be 2 of it, 3 of it, And this would have to be 4 over something right there because of how many marks I've made. I've got 4 sections. So this actually happens to be an equivalent fraction looking like something we've done in class. 1/3 is equivalent to 4 over what? And again, if they can't see it like this, they can write it horizontally. Okay, so how do I get from 1 to 4? I multiply by 4, which means I need to apply that same rule to the denominator. So 3 times 4 is 12. So that means that this has to be 4 twelfths to be equivalent to 1/3, to be in that same spot. And so that means that I was counting by 12. So that would be 1/12, 2/12, 3/12, and of course 4/12, which is 1/3. So how long is one of these sections? Right, they're each 1/12 long. So 1/3 divided by 4 equals 1/12. So that's what it looks like on a number line. You take the fraction and plot it. You take the whole number and split it into that many sections. You start counting by 1 over something that you're not sure of. So you come all the way down here. Once you've counted through and find the equivalent fraction, that lets you know the denominator of what you're counting by. So we'll do another one. So let's do 1/4 divided by 2. So it would be 0, and it would be 1/4. And again, I said, yeah, that's way larger than 1/4, but we're like expanding it so we can see it. And we're dividing by 2, which means I just need 2 sections, so I'm just going to cut it in half there. And so then I'm trying to find the length of one of these sections so that I know this is 1 over something and this is 2 over something, because 1 mark, 2 marks. And again, I've got that equivalent fraction. 1/4 equals 2 over what? Well, this would be times 2, so this would be times 2, so that would be 8. So this is 2/8, which we know that the kids know that 2/8 is equivalent to 1/4. But if that's 2/8, here's the first mark, it means that this is 1/8, which means that the distance of this one section is 1/8 long. So 1/4 divided by 2 equals 1/8. So that would be a number line. They're not required to do that on their homework. I just wanted some of them to see it because some of them saw it today and some of them didn't. And we'll talk about that tomorrow when we see them in class. So it's front loading there for the ones who didn't get to see it. So that is pretty much their homework. Of course, at the bottom of page 515, you have word problems that they're going to have to figure through. And on number 15, I told them to concentrate on the relationships they saw up top. So, number 2, number 4, number 6, they are all fractions divided by whole numbers. So I told the kids, look at the quotient. Compare that quotient to the fraction you started with. Is it greater than the fraction you started with or less than the fraction you started with? Likewise, number 8, 10, and 12 are the opposite. They're whole numbers divided by fractions. So I told them to, look at those quotients separately. Think of them differently. Here's this set over here. So think of those quotients compared to the whole number they started with, and that will help them to answer the question of number 15, which says, tell whether the quotient is greater than or less than the dividend, which is the number you start with, when you divide a whole number by a fraction, and explain your reasoning. And we have actually said this answer over and over in class today, as well as the reasoning of why. So they should be able to do that. But again, if they are having trouble with it, have them look at 8, 10, and 12, comparing the quotient that they get compared to the whole number they started with. That should help them see whether the quotient is greater than or less than what they started with the whole number. So that is it for tonight. Have a good night.